This is a presentation on developing and implementing the GEOSS Common Infrastructure. GEOSS Common Infrastructure is a common set of core services to promote the integration of the Group on Earth Observation, otherwise known as GEO, and its system of systems as a functional system of systems. So these are elements that help glue together the community to assist in the discovery of Earth observation data. The GCI includes components and services, standards and interoperability references, user requirements, some best practices, user interface through a GeoWeb portal, and a clearinghouse, which is a search facility. This common infrastructure provides a place where geo-affiliated resources can be identified, found, and applied directly or in support of one or more societal benefit areas. This provides a library or yellow pages to help navigate and discover geo-resources. Geo-resources are really a form of spatial data infrastructure resources. So we have an alignment between GEO and the GSDI. Value of the GEOSS Common Infrastructure is one of affiliation, in that if you register with GEOSS, that defines membership or participation in GEOSS. In other words, if you have a resource and it's part of GEOSS Common Infrastructure as registered, then it's part of GEOSS. Another value is that it supports discovery. Registration of systems and services lets them be discovered, searched, and browsed through GEOSS. There's also some level of integrity in terms of association of services with known standards and practices allows them to be integrated and reused, whether they're services, data, or applications. It also provides a destination, so it's a one-stop location for finding and applying geo-related resources. There are two user contexts for GEOSS. One is the publisher's point of view, whether it's a GEO member, which is a country, or a participating organization, which could be a professional group. They have a resource of interest that they would like to share with GEOSS. The other is a user point of view, where a member of the public is interested in finding information and services related to Earth observation, such as ocean, land, or atmosphere data. Here's an illustration of the GEOSS Common Infrastructure that we see within the green bubble here. We have the registries and their relationships to one another, the web portals and the clearinghouse. From the publisher view, they come in through a web portal and would contribute or nominate their resources through the component and service registry, basically saying I have a system and its services, and I'd like to associate those services with one or more standards that are listed and recognized by GEOSS. These components could be referencing a remote catalog, which would be then harvested into the clearinghouse, and by metadata reference, then you can point to the registered components and services that are out there. The user view supports both search and access on the right, where they go through the web portal to the clearinghouse to find things, or if there's again a metadata link in the clearinghouse, which is a set of metadata essentially, then the user can go on and click all the way through and find registered components and services from member countries or participating organizations. They can also access the registries directly through standard APIs. So they can perform searches on lists of standards or best practices or requirements, or even what components and services might live within GEOSS. Here's a more elaborate view of the narrated relationships, annotated relationships between each of the parts. Reading through it, you read along the direction of the arrow, so a user accesses a GeoWeb portal through a web browser up at the top there. The main Geo website links to the GeoWeb portal. GeoWeb portal links to GeoNetcast going up to the upper right there, and so on. So you can read through the diagram to understand the various relationships and how the different parts of GEOSS and the GCI within this green bubble interact. GeoWeb portals provide client access to catalogs, map services, and data services through standard-based interfaces. it's really only providing a user interface for search, which is done through the GEOSS registries and the clearinghouse. It supports a low or minimal cost of redeployment, so communities can take and apply these GeoWeb portals in their community for specific or customized use. It includes community management tools and portlets, content management capabilities, and the ability to integrate and visualize disparate resources, especially mapped and image resources through Web Map Service and KML or RSS viewers. It's a place to link or reference to end user support applications. The GEOSS Clearinghouse is an all-of-GEOSS search facility. Think of it as a search engine that's tuned for Earth observation data. It provides an API with access to metadata to search metadata on services and systems that are listed in the component and service registry. So the clearinghouse basically has a standard query interface that's used by software in order to search and retrieve or present results. So the clearinghouse communicates with the web portal, where the web portal provides a human user interface. The GEOSS clearinghouse provides a software user interface for catalogs. These registered catalog services can be made searchable. Metadata can describe systems, services, data, and documents. And the standard that's being used for the API for search is the OGC Catalog Services for the Web 2.0.2. This also has to be implemented as a client by the GeoWeb portals. Here's an example of GEOSS Clearinghouse search through a native search environment. In this case, there's a tag cloud over on the left of popular terms that have been indexed, words that have been indexed in the metadata in the current collection. And this is just a convenience interface for searching the clearinghouse that would be actually wrapped or manifest through a web portal interface. So in this case, I search for the word servir in the title. I click on Search Now, and it finds a match, which then presents a small amount of metadata. It's not a full metadata record here, because what the clearinghouse does is it pulls out only some of the fields of metadata that are searchable, the primary ones, and then if the user asks, and you click on it, you see original harvested record XML, then the full original XML record can be fetched and presented. So the catalog acts as an intermediary, kind of a light metadata catalog to going and locating the full descriptions and ultimately the data that are out there. The Standards and Interoperability Registry of GEOSS is a collection of standards and community practices that are nominated from other standard sources through a registration process by GEO individuals. So a standard that is from OGC or from ISO or some other standards organization would be nominated because it's being used by somebody in the GEO community. These nominations are processed. If they're already standards, they're associated with the standards development organization. If they're a special arrangement, then they're more of an ad hoc community practice, not yet a standard, but they can still be managed within this zone. So if within a community, say oceans, a certain protocol is being used, but it's not really an international standard, it can be endorsed here or referenced as a special arrangement. The benefit of this is that standards and these special arrangements can set up a pick list for use elsewhere, so that when somebody comes in and says, well, I'm registering a service, they can pick from a list of identified standards by name, by identifier, and simply pick from a pick list and apply it there without having to type it in. Here's an example of the front page of the GEOSS Standards Registry, where you can perform a search, propose new entries, or ask for user support. In this case, I searched on Web Map Service, and I get several things where Web Map Service is referenced. If you click on the second one, then you'll see the full description of the Web Map Service standard. If you clicked on the title, it would actually take you to the specification itself. But this provides kind of a thumbnail or a summary view of every one of the standards that somebody in GEO has nominated. Best Practices Wiki is a place to post best practices using a semi-structured format that are really, again, best practices to be shared across GEO. So if you have a special methodology that seems to work well within the community and you'd like to promote it for others to use, this is a place to reference it in narrative form. You can also have links back to other things within GEOSS, such as standards or other document types that might be relevant to explaining that practice. Here's an example of shared vocabularies. We have a subject area of data archiving. The best practice is listed here, and why, and the source document, and other basic information. User requirements registry is being designed right now to store all of the requirements from generalized or archetypical users that identify observables and their properties with respect to some kind of an application or problem set. So you may say, for local planning, I need to know change in vegetation over some period of time with some amount of some level of resolution or quality. So by matching the requirements that a specific user category has to what services or capabilities are being offered in GEO, it allows you to identify the coverage and popularity of those observation types, such as like sea surface temperature or vegetation, and identify gaps in coverage of observations to help in planning of Earth observation missions. Component and Service Registry allows for the registration of a resource we call components. These resources can be things like websites or portals or systems, and one or more related service interfaces that provide access to information. Each resource type is associated with one or more SBAs, societal benefit areas, and each entry can be associated with one or more standards or special arrangements in the Standards and Interoperability Registry. Here's an example of the Component and Service Registry interface. You can perform a search on it. You can click the Registration tab and register a resource. You can learn about programming in order to interact with it, and you can connect over to the Standards Registry. So if I select on Register here, I can register it. I can also search the registry to see what's going on, and I can jump over. There is a relationship, as you might guess, between GEOSS and spatial data infrastructures. It's not a coincidence, it's intentional that we have the same kind of standards, the same set of standards in many cases in the geospatial domain that are being adopted both for the group on Earth observation and for spatial data infrastructures. So these standards are familiar to the SDI community. It allows for a greater level of interoperability between our two communities. Where SDIs tend to focus on vector and GIS kinds of applications, the GEO traditionally has been dealing with more remotely sensed or imagery-based applications. So ideally what's happening is that the Earth observation community is now being trained to adopt and deploy resources that can be used by the SDI community and vice versa. So through adoption of these common standards, we can build on these regional and national initiatives as contributing to GEOSS. So SDIs are going to benefit from the registration of these Earth observation resources. We do recommend that SDI systems and data providers register their systems and services and services to data in the GEOSS Component and Service Registry, which is at this URL, geossregistries.info. Thank you.